This is a solution for Newton's second law, example problem number 1. A constant force pulls horizontally on a block of mass 2 kilograms, which is free to move on a frictionless horizontal surface. Starting from rest, the block is observed to move 20 meters in 2 seconds, and we want to find the value of the force. The first thing we want to do is identify the values given in the problem. And the first value that we're given here is mass. Mass is equal to 2 kilograms. The block is free to move on a frictionless horizontal surface. All that's telling us is that the only force we have to concern ourselves with is this one in the very beginning that they mentioned, of the constant force that's pulling horizontally. They also tell us that the block starts from rest. That means my initial velocity is equal to 0. The block is observed to move 20 meters in 2 seconds. So that tells me my initial position is equal to 0. My final position is equal to 20 meters. And then time is 2 seconds. They want us to find the value of the force, so force is our unknown. Okay, well, this is Newton's second law, so the equation we're ultimately going to want to use is the equation for Newton's second law, which is force is equal to mass times acceleration. Force is what we're looking for. The mass we're given to be 2 kilograms, but we don't directly know the acceleration. It's not given to us here. But we can use one of our kinematics equations to solve for acceleration. The kinematics equation we want to use is position final is equal to 1/2 acceleration times time squared plus velocity initial times time plus position initial. Position final I know to be 20 meters. Acceleration is what I'm looking to solve for. Time I know to be 2 seconds. Velocity initial I know to be 0, so that term becomes a 0. And position initial I know to be a 0, so that term goes to 0. So we can rewrite the equation now solving for acceleration. Acceleration is going to equal 2 times position final divided by time squared. So that, substituting in the values that we know, acceleration is equal to 2 times position final is 20 meters divided by time, which was 2 seconds, squared. So my acceleration is equal to 40 meters divided by 4 seconds squared, or 10 meters per second squared. Now that I have my acceleration, I can go back and use my equation for Newton's second law to solve for the force. So force is equal to mass times acceleration. So the force is equal to 2 kilograms. I'm sorry, force is equal to mass times acceleration. So the mass is 2 kilograms. The acceleration is 10 meters per second squared, which I found up above. So my force is equal to 20. The units on that would be kilogram, meter per second squared. But we know that that unit is a Newton, and those are our units that we use for force. So the force needed to accelerate that object is 20 newtons.